chemical reactions like going to a dance. This isn't a joke today. This is our lesson. Today we're going to find out the types of reactions and we're going to relate them to going to the dance. Our first one is called the synthesis, or as I like to call it, the hookup. Okay, so here's what we have going on today. So little Eddie gets to the dance and he sees across that dance floor, ooh, look at her. And he slickly makes his way across the dance floor. Hey baby, wanna dance? And the next thing you know, the music starts to play and the magic starts to happen. Okay, this first reaction that we're talking about is called the synthesis. And the synthesis reaction is a lot like when you meet somebody at the dance, So you're ready to dance with this person, and there I am. Hey, there we are. And so you want to dance with this person, so you ask them to dance. And what we have here is a chemical reaction that's going to look like that. Right now, again, for this synthesis, we have two individuals, a positive ion and a negative ion. And if you notice up here with my little picture, that's not just a smile on her face because she met little Eddie. That is a negative sign and a positive sign. All right? We just treat this like a reaction. How do they go together? Well, the two separate ions join to form one. So Na, which is +1, I is -1. Now, if you're worried about diatomic stuff, diatomics only come into play when it's all by itself. Like this I over here by itself, it's diatomic. Here, the I is going to be in a compound, so you don't have to worry about it. It can be any number. The number is determined by our charges. We have +1, we have -1. If you want to put ones down here, nobody really does that, but you can do that. All right? And now our formulas are sound. We have two i's on this side of the equation. We only have one over there. Hey, let's fix that with a big coefficient too. That gives me two NAs and two NAs. All right, let's proceed. Now what I want you to do is I want you to explain how this synthesis reaction relates to that dance. All right, and then I also want you to balance the following equation. All right, let's move on. All right, our second type of dance. And Miss Purple over there, but things are about to change. All right, so what we got going on here is a new guy enters the dance, and he says, I think I would like to cut in. And cut in means, for you who don't know, it means to come over here and, hey, do you mind if I dance with her? Thought. She decides, hey, yeah, I think I would like to dance with him. And little Eddie is out of the loop and heading towards the door. Okay, now that reaction right there is what we call single displacement. Sometimes you call it single replacement, and I call it the cut in because they're cutting into the dance. Now, there's two different ways this can happen. Way number one can be with positive replacing positive. So in my analogy, I'm using the boys as positives and the girls as negative. And the positive replaces the positive. And so one guy replaces the other and the other one hits the road. It also can happen where a negative replaces a negative. So you have to look at those charges. Only positive can replace positive. Only negative can replace negative. All right, let's get this back to size. All right, now I made a few of these to balance. Again, I'm going to balance one, and it's your job to Number one, explain this dance analogy. You can do it in picture form if you'd like. Or, and balance this equation. So I'm just going to do the top one. Look at the top one is positives, the bottom one is negative. Surprise, surprise, right? That's my style. Okay, so here's what we have. We have FE, and what is FE going to replace? Right? FE is plus 3, so FE has to replace the plus 2, the CU. So it's going to replace the CU, and it's going to be with NO3. Now, we're not dragging any subscripts across that line unless they're in parentheses, unless they're polyatomic ions. So don't take that 2 over there that's outside this parentheses. Don't take this 2 because that 2 is only there because of the charge of the Cu. Now, once we get them with their new partners, we're going to adjust the formula with our charges. So Fe was plus 3, nitrate was minus 1. We need a 3 here instead. All right, that's how it works. And then Cu gets kicked out. Is Cu diatomic? No. Are we worried about its charge? No, it's by itself. You don't have to worry about its charge. Okay, now that formula is fixed. This formula is fixed. Now it's time to balance. It looks like we have 3 nitrates over here and only 2 over here. Well, that's a weird one. We're going to have to make them both the least common multiple, which would be 6, right? So we put a 3 here and a 2 here. That fixes our nitrates. Now let's fix our Fe since we started here. That gives us 2 Fe's, 2 Fe's. Let's fix our Cus. 3 Cus, 3 Cus, and it's done. Okay, single replacement reaction. Make sure that you balance this one, and don't forget to write your analogy. We're in a situation where you're dancing with a girl and you decide that maybe you want to dance with that other girl over there, but she's dancing with someone else. What do? The old switcheroo. That's right. You change dance partners. And by changing dance partners, by changing dance partners, maybe you get an extra arm in there. You know, you're going to find yourself a little bit happier. Well, the same thing happens here in the old double replacement reaction. Now, in the double replacement reaction, it's the rules where the guy, where are they dancing at? Hey, there they are. Hey, guys, you get out of there. No hiding in the corner. And they're dancing there, dancing right along. And they switched partners over, and now everybody's happier. All right? That's what we're going to call the double displacement, or sometimes the double replacement. And so we have A, which is generic for positive, X negative, B, and Y. And then they switch partners. All right? So I want you to, you'll never guess, explain this with a dance analogy. And you can, if you want to, draw pictures to show it, or you can write it out in words. I don't care. But what we're going to do next is we're going to do this in real life here. I'm going to pick the bottom one because, I don't know, there's space. So we have Ca. And Ca is going to, let me change the size of this pen a little bit. And Ca is going to switch places with the H. How do I know? Because they're both the positives. So Ca is plus 2. Make sure you write that charge up there. PO4 is minus 3. Again, we're not taking any subscripts across the yield sign unless it's a polyatomic ion inside that parentheses. Then we can take it because those subscripts are coming from the charges of those ions. So we're going to take a 3 down here and a 2 there, the old crisscross. And then we have H, which is plus 1. And then we have OH, which is minus 1. Hi, Mrs. Hoffbauer.
I'm going to eat her step.
Oh, okay. You want to come and say hi to my class?
Sure. Who am I saying hi to?
I don't know. Chemistry kids. All right. So now, notice we didn't bring those subscripts over because we have plus and we have minus.
Bonus points if they knew who came to visit you in your meeting today.
I don't give bonus points. Don't listen to what she says. So it's plus and there's a minus. And so once those formulas are right, we make them right. Again, don't take your subscripts across the yield sign. And now we have to balance. So let's start with this most obnoxious. There's 3 CAs here. Let's put a 3 here. That gives me 6 OHs. So I'm going to put a 6 here. Look, I'm doing the OHs separate. It's a little trick. If you have a hydroxide on one side, you know what? Make water HOH. It's going to work out really good for you. Now we have 6 H pluses, right? And we had 3 H pluses over here. Let's put a 2 in front of that. That'll be 6. And we're back to where we started with a 1. All right? Double replacement. Okay? Any questions about that? Okay. I'll see you in a second. Hard to do. And our last reaction we're going to talk about today is called decomposition, which is the breakup reaction. Right? You're getting along fine. Next thing you know, poof. You're separate. You're walking away. You're splitting up. And that's what that's our last reaction. It's called the decomposition. And you might know the word decomposition if you watch those crime shows because, right, the decomposition, the breaking up of the chemicals in the body. There are all sorts of different kinds of decomposition reactions. So when you do decomposition, it's a little bit different because in this case, it's all based on what's together. And so let's look at these really quick. Now I have examples up here. So if it's a carbonate, and this first example is calcium carbonate. So if it's a calcium carbonate, or just I should say if it's a carbonate, when it decomposes, it forms a compound with the cation and an oxygen. So it forms the metal oxide and then carbon dioxide. It follows that pattern. So it's going to be your job to take this magnesium carbonate and split it apart just the way that I split up the calcium carbonate. Follow the same pattern. Now it's going to balance different because it's different compounds. Well, they're both +2. So this one may not balance very much different, but sometimes they balance difference because they're different compounds. All right, let's look at the next one. This next one is a hydroxide. So it's with an OH. So if you have calcium hydroxide, right, when it splits apart, it's going to form the calcium oxide again, or a metal oxide, and then it's going to form water in the form of gas with each other thing. So calcium hydroxide forms calcium oxide plus water. And so your example you're going to balance is lead oxide or lead hydroxide, and it's going to break apart and it's going to form lead oxide and water, and you'll be responsible for balancing that out. Now make sure you realize that's lead 4. Okay. The next one is going to be a chlorates. So the chlorates, we have potassium chlorate, breaks apart into potassium chloride and then free oxygen. All right. So that means the sodium chlorate is going to break apart and form sodium chloride plus oxygen. All right, and you'll have to balance that out. And the last one is going to be when we heat when we heat some acids and they form into non-metallic oxides in water. And so we have right here, we have, here's an acid. We know it's an acid because it starts with an H, and it's with a carbonate, all right? And it's going to split apart, and it's going to form carbon dioxide and water. So here we have an acid, and this acid, again, it starts with an H, and this time it's SO3. All right, so what's it going to form? SO2 plus water, and you'll have to balance that out. And the last one was water, and I didn't have any other examples, so I left it be. Okay, so let's review really quick. We have four main types of reactions that you're going to be responsible for knowing. One is going to be synthesis, where they join together. And my picture is going to be all weird because I had to draw between each one. So we're going to have synthesis, where two things are going to join together. We're going to have single replacement, where one comes in and replaces the other, kicks out the other dancer. So you have a couple, you have a single, and then the one person comes in and replaces the other. Remember, like charges replace like charges. Then you have the double replacement or double displacement, where they switch partners. And then finally, we have the decomposition, which is the breakup, where they split up. They may not split up pretty. As you can see from these, they're not pretty, but breakups rarely are pretty. And that's all I have today. We'll leave with that. Have a great day.